Hello. Antes de irme a dormir, tenía ganas de compartir. Es que llevo días pensando, quiero grabar este video y aquí estoy porque no me quiero quedar con las ganas. Es un fragmento de este libro, Cartas a un joven matemático, que es muy específico de por qué la matemática es tan linda, de por qué. ¿Por qué la matemática? Y así se titula el capítulo que les quiero leer. Así que voy a compartir mi pantalla ahora mismo. ¡Yay! ¿Listo? Bueno, es de verdad muy bueno, así que por eso de verdad se los quiero compartir. Así que comencemos. The truth is that we encounter mathematicians everywhere, every day, but we hardly ever know it. Past students of mine have managed breweries, started their own electronics companies, designed automobiles, created software for computers, and traded futures on the stock market. It simply doesn't occur to us that our bank manager might have a degree in math, or that the people who invent or manufacture DVDs and MP3 players employ large numbers of mathematicians. Yo digo que sí, eso por lo menos es obvio. Or that the technology that transmits those stunning pictures of the moons of Jupiter relies heavily on math. Hay que saber que ahí hay matemática, o sea, es posible que esos ejemplos no, pero es que luego adelante él pone unos ejemplos en que uno dice como, ahí también hay matemática, sorprendente. We know that our doctor has a medical degree and our lawyer has a law degree, because those are specific, well-defined professions that require equally specific training. But you don't find brass plaques on buildings advertising a licensed mathematician within who, for a large fee, will solve any math problems that you need help with. Our society consumes an awful lot of math, but it all happens behind the scenes. The reason is straightforward. That's where it belongs. When you drive a car, you don't want to have to worry about all the complicated mechanical things that make it work. You want to get in and drive away. Sure, it helps you to be a better driver if you're aware of the basics of car mechanics, but even that is not essential. It's the same with math. You want your car navigation system to give you directions without your having to do the math yourself. You want your phone to work without your having to understand signal processing and error correcting codes, lo cual es una locura. O sea, si uno se pone a pensar, eso es Google Maps, eso es Uber, eso es todo. O sea, la sincronización que una aplicación te diga, bueno, tú vas a estar allá en el minuto 5:23. Es como, ¿what? A mí eso me parece brutal. O que entre todos los autos que haya en la ciudad, justo como hagamos match, como yo como usuaria y el carro que me va a ofrecer el servicio del ride, eso sí me parece una locura. Así que me quedo sin baba, perdón. Some of us, however, need to know how to do the math, or none of these wonders could function. It would be great if the rest of us were aware of just how strongly we relied on mathematics in our daily lives. The problem with putting math so far behind the scenes is that many people have no idea it's there at all. Y es por eso que se conecta mucho con el libro de Christopher Steiner, de Automate This, que es como de verdad el futuro le pertenece a las personas que están automatizando, a las personas que hacen código y que los matemáticos, por eso que ganan lo que ganan, ¿me entienden? I sometimes think that the best way to change the public attitude to math would be to stick a red label on everything that uses mathematics. Math inside. There will be a label on every computer, of course, and I suppose if we were to take the idea literally, we ought to slap one on every math teacher. But we should also place a red math sticker on every airline ticket, every telephone, every car, every airplane, every traffic light, every vegetable. ¿Vegetable? Yes, mi querido rinoceronte. The days when farmers simply planted what their fathers had planted and their fathers before them are long gone. Virtually any plant you can buy is the outcome of a long and complicated commercial breeding program. The whole topic of experimental design in the mathematical sense was invented in the early 19th to provide a systematic way to assess new breeds of plants, not to mention the newer methods of genetic modification. Wait, isn't this biology? Biology, sure, but math too. Genetics was one of the first parts of biology to go mathematical. The Human Genome Project succeeded because of a lot of clever work by biologists, but a vital feature of the entire project was the development of powerful mathematical methods to analyze the experimental results and reconstruct accurate genetic sequence from very fragmentary data. So vegetables get a red sticker. Just about everything there is gets a red sticker. Okay. You go to movies? Do you like these special effects? Star Wars, Lord of the Rings, mathematics. The first full-length computer-animated movie, Toy Story, led to the publication of about 20 research papers on math. Computers, graphics. Isn't just computers making pictures, it's the mathematical methods that make those pictures look realistic. To do that, you need three-dimensional. Ya me enredé la lengua. Wait. Toy Story led to the publication of about 20 research papers on math. Computers graphics isn't just computers making pictures. It's the mathematical methods that make those pictures look realistic. To do that, you need three-dimensional geometry, the mathematics of light, in between it to interpolate a smooth series of images between a start and a finish and lots more. That's like game developers or game designers, better, yeah, game design. O sea, yo estoy viendo a un youtuber que él lo que hace es desarrollar juegos, ¿no? Pero la parte que más se le dificulta es que, bueno, él juega unos juegos, sí es gamer, de unos como Fortnite o así Call of Duty, que tienen gráficos muy buenos y que luego cuando él quiere armar su juego es como, el mío se ve como un mamarracho terrible al lado de esos, pero es por toda la información que se recopila y que luego se logra poner en three-dimensional geometry, right? Interpolation is a mathematical idea. Computers are clever engineering, but they don't do anything useful without a lot of clever math. Red sticker. And then, of course, there is the internet. If anything makes use of math, it's the internet. The main search engine at the moment, Google, was founded on a mathematical method for working out which web pages are most likely to contain the information required by a user. It's based on matrix algebra, probability theory, and the combinatorics of networks. But the math of the internet is much more fundamental than that. The telephone network relies on math. It's not like the old days when switchboard operators literally connected calls by plugging phone lines in by hand. Today, those lines have to carry millions of messages at once. There are so many of us all wanting to talk to our friends or send faxes or access the internet that we have to share the phone lines and the suboceanic cables and the satellite relays, or the network wouldn't be able to carry all that traffic. So each conversation is broken up into thousands upon thousands of short pieces, and only one piece in 100 is actually transmitted. At the other end, the missing 99 pieces are restored by filling in the gaps as smoothly as possible. It works because the samples, thought short, are very frequent, so that the sounds you make when you speak change much more slowly than the interval between samples. Oh, and the entire signal is coded so that any transmission errors can not only be detected, they can be put right at the receiving end. Modern communication systems simply wouldn't work without a huge quantity of math. Coding theory, Fourier analysis, signal processing. Anyway, you go onto the internet to get a plane ticket, book your flight, and turn up at the airport, hop on the plane, and away you go. The plane flies because the engineers who designed it used the mathematics of fluid flow, aerodynamics to make sure it will stay up. It navigates using a global positioning system, GPS, a system of satellites whose signals analyzed mathematically can tell you where you are to within a few feet. The flights have to be scheduled so that each plane is in the right place when it is next needed, rather than somewhere on the far side of the globe, and that again requires yet other areas of math. And so, Meg, my dear, it goes. You ask me whether mathematicians are all shut away in universities or whether some of them do work related to real life. Your entire life bobs like a small boat on a vast ocean of mathematics, but hardly anyone notices. Hiding the math away makes us all feel comfortable, but it devalues mathematics. That is a shame. It makes people think that math isn't useful, that it doesn't matter, that it's just intellectual gains without any true significance, which is why I like to see those red stickers. In fact, the best reason not to use them is that most of the planet will be covered with them. Your third question was the most important and the saddest. You asked me whether you will have to give up your sense of beauty to study mathematics, whether everything will become just numbers and equations to you, laws and formulas. Rest assured, Meg, I don't blame you for asking this, since it's unfortunately a very common idea, but it couldn't be more wrong. It's exactly the opposite of the truth. What math does for me is this. It makes me aware of the world I inhabit in an entirely new way. It opens my eyes to nature's laws and patterns. It offers an entirely new experience of beauty. When I see a rainbow, for instance, I don't just see a bright, multicolored arc across the sky. I don't just see the effect of raindrops on sunlight. Wait, when I see a rainbow, for instance, I don't just see a bright, multicolored arc across the sky. I don't just see the effect of raindrops on sunlight, splitting the white light from the sun into its constituent colors. I still find rainbows beautiful and inspiring, but I appreciate that there's more to a rainbow than mere refraction of light. The colors are, so to speak, a red and blue and green herring. What require explanation are the shape and the brightness. Why is it a rainbow a circular arc? Why is the light from the rainbow so bright? You may not have thought about those questions. You know that a rainbow appears when sunlight is refracted by tiny droplets of water, with each color of light being diverted through a slightly different angle and bouncing back from the raindrops to meet the observing eye. But if that's all there is to a rainbow, why don't the billions of different colored light rays from billions of raindrops just overlap and smear out? The answer lies in the geometry of the rainbow. When the light bounces around inside a raindrop, the spherical shape of the drop causes the light to emerge with a very strong focus along a particular direction. Each drop, in effect, emits a bright cone of light, or rather, each color of light forms its own cone, and the angle of the cone is slightly different for each color. When we look at a rainbow, Our eyes detect only the cones that come from raindrops lying in particular directions. And for each color, those directions form a circle in the sky. So we see lots of concentric circles, one for each color. The rainbow that you see, esta es la parte que más me gusta. The rainbow that you see and the rainbow that I see are created by different raindrops. Our eyes are in different places, so we detect different cones produced by different drops. Rainbows are personal. Some people think that this kind of understanding spoils the emotional experience. I think this is rubbish. It demonstrates a depressing sort of aesthetic complacency. People who make such statements often like to pretend they are poetic types, wide open to the world's wonder, but in fact they suffer from a serious lack of curiosity. They refuse to believe the world is more wonderful than their own limited imaginations. Nature is always deeper, richer, and more interesting than you thought, and mathematics gives you a very powerful way to appreciate this. The ability to understand is one of the most important differences between human beings and other animals, and we should value it. Lots of animals emote, but as far as we know, only humans think rationally. I'd say that my understanding of the geometry of the rainbows adds a new dimension to its beauty. It doesn't take anything away from the emotional experience. The rainbow is just one example. I also look at animals differently because I'm aware of the mathematical patterns that underlie their movements. When I look at a crystal, I'm aware of the beauties of its atomic lattice as well as the charm of its colors. I see mathematics in waves and sand dunes, in the rising and the setting of the sun, in raindrops splashing in a puddle, even in birds sitting on telephone cables. And I'm aware, dimly, as in looking out over a foggy ocean, of the infinity of things we don't know about these everyday wonders. Then there is the inner beauty of mathematics, which should not be underrated. Math done for its own sake can be exquisitely beautiful and elegant. Not the sums we all do at school. As individuals, those are most ugly and formless, although the general principles that govern them have their own kind of beauty. It's the ideas, the generalities, the sudden flashes of insight, the realization that trying to trisect an angle with a straight edge and compass it like trying to prove that 3 is an even number, that it makes perfect sense so that you can construct a regular 7-sided polygon, but you can construct one with 17 sides. That there is no way to untie an overhand knot, and why some infinities are bigger than others, whereas some that ought to be bigger are actually equal. That the only square number other than 1, if you want to be picky, that is the sum of consecutive squares. 1, 4, 9 is the number 4. How should I read it? 4,900. You, Meg, have the potential to become an accomplished mathematician. You have a logical mind and also an inquiring one. You're not convinced by back arguments. You want to see the details and check them out for yourself. You don't just want to know how to make things work. You want to know why they work. And your letter made me hope that you'll come to see mathematics as I see it, as something fascinating and beautiful, a way of seeing the world that is like no other. I hope this sets the scene for you. Bueno, para ustedes, para mí también creo que lo ha hecho. La explicación del arco iris ha sido mi favorita, y de verdad pensar que a todo le podemos, bueno, no a todo directamente, pero que de verdad hay muchas cosas en la vida, de los objetos, personas, animalitos, o como situaciones a las que en efecto podríamos poner un sticker rojo y que por eso la matemática está en todas partes de nuestras vidas. Espero les haya gustado tanto como me gustó a mí. Me despido.